Hello everyone, good evening. So welcome to the session 13 of work, energy and power topic. In Canada, we'll start with the idea of collisions. Okay, wow. So up to the session 12, we were looking at the applications of the work energy theorem, right? So in Canada, we'll start with the concept of collisions. But collisions, we'll emphasize on this concept called as momentum. Or the momentum is kinetic energy. Okay. So before we go and discuss collisions, right, we will look at what is the relation between the momentum of an object and the kinetic energy. In a momentum and we already discussed about it. And the kinetic energy expression is cover. But in Canada, we look at what is the relation between the momentum and the kinetic energy of the object. Okay. So for an object which is having a mass m and speed v. Okay, what is the magnitude of the momentum m into v? What is the momentum of magnitude m into v? And kinetic energy, let us represent this by the symbol E and vechkonga. What is the kinetic energy? E will be equal to what? Half m into the v square. Okay, so if you just square momentum, square m square v square. Okay, we will divide this by m. Divide what you will get? Or m cancel m v square. So p square by m m v square. Half which multiply half into p square by m, that is equal to what in the half into m v square. Kinetic energy. So what is the kinetic energy relation to the momentum? P square by 2m is equal to kinetic energy. In the expression, like if you are having the momentum value and mass of the object and the two quantities, we will be able to find out what is the kinetic energy of the object. Okay, so in the formulas use not only in here but even in other places, right? Substitution the relations will be useful. We even got, I think, at least 4 or 5 questions have come based on the relation between the linear momentum and kinetic energy. So this is one relation. When we are looking for the kinetic energy value related to the momentum and mass. Okay, so this one. In the expression, p square. We want to have p square means, so p square will be what? Up on the 2m right side, it will go to the numerator. So 2m into e varum. Square root what you will get? P is equal to what? Root of 2me. This is the second expression. When we are trying to find second expression, what is second expression? P is equal to root 2me. When we are looking to find the value of the momentum. Now get a kinetic energy and mass of the object. And the quantities we will be able to find the momentum. What is the relation? P will be equal to what? P value root 2me. Okay. In the relations based already from this chapter only, right? We got, I think, at least 4 or 5 times they have asked questions. What are the two relations we have? P square by 2m is equal to kinetic energy, and the momentum is equal to what? Root 2m into kinetic energy. Okay, so E is what? Kinetic energy. What kind of questions have come? This is a question that has come in the 1993. Two masses, 1 gram and 9 gram, are moving with equal kinetic energies. So the kinetic energy value E and H. So both of them are having the same value. The ratio of their magnitudes of respective linear momenta. The linear momenta ratio. So what is it? What is the formula we have? P is equal to root 2me. What is the linear momentum formula? P is equal to what? Root 2me. So the linear momenta ratio. So what is P1 by P2? Root 2 m1 into E. and first object mass evla 1 gram, that is, let us call it as m1 ichukonga. Idanadi m2. p2 evla root 2 times m2 into e. Inga enna theriyuma, root 2 cancel aidum. நம்ம அந்த மிஸ்டேக் பண்ணக்கூடாது. என்னது, சம்டைம்ஸ் people do this very casual mistake. அப்படியே மேலே கீழே ரூட் கேன்சல் பண்ணி they will try to get the answer. ரூட் கேன்சல் ஆகாது. ஓகேவா? ஸோ ரூட் டூ கேன்சல் ஆகிடும். அதுக்கப்புறம் ரூட் இ கேன்சல் பண்ணலாம். ஸோ என்ன இருக்கா, root of m1 by m2. பாருங்க, what is m1? 1 gram. m2 எவ்வளோ? 9 grams. கிராம் கேன்சல் ஆகிடும். what is root of 1 by 9? 9. ரூட்லேருந்து வெளியே வந்தால் it will be what? 3, right? so p1 by p2 எவ்வளோ? 1 by 3. செக் பண்ணுங்க, what is the answer? what is the ratio of the momentum? இதெல்லாம் என்ன, straight forward questions. okay, so இந்த மாதிரி questions வந்தா we should not take much time. so formula base பண்ணி we can get the answer straight away. okay va? so what is the ratio of the good? I think Janani, good. okay, so the ratio என்ன, p1 by p2 எவ்வளோ? 1:3. அவ்வளோதான். இந்த ரெண்டு ஃபார்முலாஸ் மட்டும் நமக்கு ஞாபகம் வச்சுக்கணும். what is it? p is equal to root 2me. அது ஒன்று. ரெண்டாவது என்ன, p square by 2m is equal to e. what about the others? check பண்ணுங்க அதிதி, good. okay, so அடுத்த question போலாமா? so this is another question. இது எப்போ வந்தது? 2002. if kinetic energy of a body is increased by 300%, எவ்வளோ பர்சன்டேஜ் இன்க்ரீஸ் பண்ணிட்டாங்க? 300% இன்க்ரீஸ் பண்ணிட்டாங்க. ஓகேவா? then the percentage change in the momentum. okay, so இங்க என்னன்னா நோட்டேஷன்ஸே கொடுக்கலாம். அப்போ நம்ம என்ன பண்ணணும்? we will consider the object mass as m. okay, அதுக்கப்புறம் initial energy e ன்னு வச்சுக்கோங்க. okay, is increased by 300% னு சொல்றாங்க. see, இந்த மாதிரி क्वेश्चंस என்னன்னா wordings நம்ம ரொம்ப கேர்ஃபுல்லா இருக்கணும். இல்லனா we will get a completely different answer. increased by 300%. see, first of all, 300% of energy and சொன்னா what is it? initial energy எவ்வளவு? e into 300 by 100. அப்படிதானா? so what is it? 3e. so this is 300% of the energy. so question statement படிச்சு பாருங்க ஒரு தடவை. what is it? if the kinetic energy of the body is increased by 300% means initially எவ்வளவு இருக்கா? e. so final energy பாருங்க. so final energy will be what? final energy will be e plus we are increasing by 300% means e plus 3e வரும். அதனால 4e. okay, so when we'll look at initial momentum p. what is p oda value? root 2me. அதுதானா? so final momentum p dash ன்னு சொல்லலாம். what is p dash? root 2 mass அப்படியே இருக்கும், constant. இங்க energy எவ்வளவு? final stateல 4 times of e. final stateல energy எவ்வளவு? 4 times of e. பாருங்க, இதுல இருந்து அப்படியே அந்த 4 நம்ம வெளியே எடுத்துட்டு வந்தா what is it? rootல இருந்து if you are taking the 4 out means it will become what? 2 times of root 2me. இது என்னது? initial momentum தானா? so what is it? 2 times p. so பாருங்க, p dash எவ்வளவு? p dash is what? 2 times of p. so இப்போ நமக்கு என்ன வேணும்? the percentage change in the momentum. we are looking for what? percentage change. percentage change and சொன்னா what is it? delta p, change in the momentum by initial momentum into 100. அதுதானா? what is the percentage change in momentum formula? percentage change in momentum and சொன்னா what is the formula? what is it? change in momentum, okay, divide by initial momentum into 100. அதுதானா? what is change in momentum means p dash minus p. initial momentum எவ்வளவு? p. so p dash எவ்வளவு? 2p. பாருங்க, 2p minus p means p தானா? so what is it? எவ்வளவு? it is what? 100%. actually இங்க என்ன இருக்கா? the momentum is increasing by 100%. the momentum is actually increasing by 100%. okay va? so check it guys whether you are getting the same answer or not. இதெல்லாம் straightforward questions. okay, good Aditi. Okay va, so what is it? The momentum is actually increasing by 100%. Okay, so there is a chance that we can get here already. I think if you look at the past years, right, 4-5 times in the மாதிரி questions வந்தது. So there can be a chance to get these kind of questions. See, இந்த மாதிரி questions வந்தது தெரியுமா, solve பண்றது பெரிய issue கிடையாது. Okay, so a lot of people can solve, but என்னன்னா if you are preparing properly means you should solve this kind of question in less than a minute. Okay, there will be some questions which will take more time. So if you're taking, like 1.5 minutes அந்த மாதிரி இந்த மாதிரி questions நீங்க டைம் எடுத்தா, then you will be on the losing side. Okay, so straight forward formula based questions என்னன்னா we should be, நம்ம approach எப்படி இருக்கணும், we should be able to not just solve them, solve பண்றது மட்டும் கிடையாது, we should be able to solve them in that less than that 1 minute. அப்பதான் நமக்கு அந்த advantage கிடைக்கும். ஓகேவா? So that is how we have to keep our focus when it comes to questions like this. So this is about the relation between the momentum and the kinetic energy of a single object. Okay, so now we will talk about the collisions. Okay, so paranga, what are you seeing here? It is like two celestial bodies which are actually, crashing into one another. The collision and solama, can we call it as a collision? Yes, we can call it as a collision. But once the collision is happening, right, the bodies are getting deformed. Okay, so what is the collisions may not create deformation in that object, but in the bodies are actually colliding and then they are deforming each other. Okay, so this can be actually called as a collision. But in our syllabus, right, நம்ம இந்த மாதிரி collisions எல்லாம் நம்ம ஸ்டடி பண்ண போறது கிடையாது. We will talk about the simple type of collisions. Okay, so இங்க பாருங்க, what is happening here? This is a person who is actually, he is colliding with the ground. Paranga, he is trying to catch the ball and he is colliding with the baseball, right? So if you are trying to catch the ball, you are not able to catch it, means what is the situations, you will be falling onto the ground. What is it? This is collision dana. So the person is colliding with the ground. Okay, of course there will not be much deformation. The person is able to get up and then walk normally. Okay, so obviously sports persons they will get the training. Okay, so that when they are falling off, in what posture they need to fall, adella avanga training la varum. Okay va, so this is also a collision that we will generally see. Inga paranga, what is happening here? So this is a football game where two guys are actually bumping onto each other. So this is also collision, right? What is it? Two people are colliding with each other. Okay, so it can happen in a lot of normal fights also, it will happen, right? So when you are going and hitting the other person, it's also collision. So when you're punching the other person, that is also collision. Okay, of course we should not do all these things, but this can be also taken as an example for the collision. Okay, so inga paranga, what is this? So it's a accident, but luckily enna paranga, if you observe carefully, right, the person is able to just get out safely. Onnu agala, so nobody has got injured. Even the car got actually rammed, both these cars. Okay, so both these cars got rammed into each other, but the driver is able to come out safe. Okay va, so this is also collision, right? What is it? Here the cars are actually colliding. So all these are generally what we will take as an example for the collision in our common understanding. Okay, but how do we define the idea of collision in the context of physics? Okay, so because we have to define it, right? So we define it like a phenomena. So how we are going to define the collision as a phenomena, we will have to see. Inga paranga, this is another example. So what is it? This is like a small ball or something. Even you can take it like an example of a gas molecule. Okay, so you can take it as an example like a gas molecule. So we'll study about this when we go to kinetic theory of gas chapter. Okay, paranga, what is happening? This gas molecule or something is able to continuously collide with the walls of the container. Then the container மாதிரி நீங்க வச்சுக்கலாம். So this is a container. The gas molecule is able to collide continuously with the walls of the container. Okay, but this is also an example of the collision. Okay, so all these are different types of examples we can think of to understand the concept of collision. But enna sonna madiri we have to define this collision. Okay, paranga, collision எப்படி நம்ம டிஃபைன் பண்றது? It is always defined as an isolated event. So isolated, what is the meaning of the isolated? We will discuss about it. Okay va? So collision, how do you define the collision phenomena? Isolated event. Okay, in which a strong force of interaction acts between two or more bodies for a short time, as a result of which the energy and momentum of each interacting particle might change. So paranga, what is happening? So during that collision time, which will be very short, so the collision time, right, is going to be very, very short. Okay, it's a very short time. What we will be able to observe or see is that there will be a large amount of interaction force that will be acting between these objects. Okay, so and the interaction force eppadi varudhu solittu we will try to understand as we go and discuss more about it. But what is going to happen in the short span of time? There will be the large amount of interaction force that will be acting between these two objects. Adanal enna agum? What is the observable things that we see? Anyway, we will be able to see that the momentum of the particles or the energy of the particles might actually undergo a change. Okay, sometimes we will see some noticeable physical deformations. Adella nama paaka mudiyum, like we can see some sound coming, heat coming, adella nadakum. Okay, so but this is how we will be able to define the concept of collision phenomena. Okay, so idhula enna important points paranga, one isolated event and sollirukom, that is one. Rendavathu, we talked about a strong interaction force which is operating for that short time. In the collision or a short time there is a strong force. Strong force, what is it? A force of very high magnitude. Another, what is it? That interaction force is going to be what? A force of very high magnitude. Adanala, what you are able to see as an observable thing, we will see that the momentum and the kinetic energy of the particles might change. Adillame, in most of the cases, what do you observe? You will see that sound may be produced, heat may be produced, light may be produced, deformation may be caused in the objects. Okay va? So this is how we will define the concept of collisions. But like whenever we hear the word collision, right, namaku or idea enna varuna, like we will think that there is actually a physical, inga parunga, like what you are able to see, one ball is able to physically go and touch the other object. So what we think is collision means there is a physical touch that is happening between these two objects. But we can have collisions without the real physical touch happening also. Okay, so generally collision and sonna, what is the thing that we will think of? Okay, one object is there, it is able to hit the other. So we will be thinking of the physical touch that is happening between the objects. But there can be collisions where the physical touch need not be there. Okay, Pakala, we will talk about this. Okay, so paranga, the collision, right, may or may not have a real physical touch. So normally when you look at, like the example, like the balls, like even if you look at the billiard balls, right, the billiard ball example, but we will discuss about it when we go to the study of the types of collision. Other we will talk about this collision between the billiard balls. Billiard balls and another, like you will have the billiards table, right, you will have these balls. So the collision between these billiard balls, one ball will be actually able to go and collide with the other billiard ball. And if you look at the collision between the ball and bat in a cricket or baseball, whatever the game, right, what do you see? There is a physical contact. Okay, so these are the type of collisions where we will actually have a physical contact, real touch irukum. But there can be other type of collisions where the real physical touch might not be there. Already you would have studied this in chemistry. So chemistry atomic structure chapter and you would have talked about this Rutherford's alpha ray scattering experiment. If you are having the atom of a very high atomic mass element like a gold or something, Rutherford's alpha ray scattering experiment is what? He has taken a very thin gold foil. At that he has bombarded this gold foil with alpha rays. He was able to make the observations. Like most of the alpha rays go undeviated, small amount of them are deviating by a small angle, even minute fraction of them are bouncing back. Okay, so other than alpha ray scattering experimented observations. But when you look at an alpha particle, which is colliding with the nucleus. So alpha particle and sonnanade, it is a positive charge. What is alpha particle? Helium nucleus or helium 2 plus ion. That's an alpha particle. Nucleus is what? For the gold atom, what is nucleus going to have? Positive charge. So can a positive charge and positive charge really come and touch each other? They will not be able to touch. Enna agum theriyuma? The electrostatic repulsions and the rendu thirudal, there will be what? Electrostatic repulsion, because positive charge and positive repel each other. The electrostatic repulsion, because of that, the alpha particle would get deviated from its path even before really having a physical touch with the nucleus of the gold. So on the physical touch varadhukku munnadiye, it will be what? It will get deviated. So you will also call this as a collision. Because there is an impact. So the impact and so on, it is not necessarily the physical impact. So when the alpha particle is going towards the nucleus, there is an impact that they both are able to create. The alpha particle is actually getting deviated. Okay, va? So this is an example of what? The collision where there will be no physical contact. Okay. So eppadi nama collision and sonna eppadi nama yoshikala? What is it? It's like two objects, they are able to impact each other. More particularly, they are able to impact the motion of each other. Okay. So majority of the cases there will be because of the physical contact. But there can be examples like this also, particularly if you are looking at the collision between two like charged particles. The alpha particle is positive charge. And nucleus also what? Positive charge. These kind of interactions are what? Collisions without having a physical contact. Okay, va? So this is about the idea of collision, whether we need to compulsorily have a physical contact or without physical contact also we can have collisions. Like the collisions between like charged particles. Okay, va? Now collision process, the collision phenomena, we can divide the collision phenomena into 3 stages. Okay, va? 3 stages, 3 stages we divide pannalam. Eppadi parunga? Like say for example, you are having and the balls for example and medical. So this is ball 1 and this is ball 2. First there will be what you call as a relative approach and solala. Relative approach and theriyuma? Object 1 will be moving, object 2 also might be moving. Okay, but relative approach and if you are trying to study the motion with respect to one of them, with respect to 2 nam observe panna, it will look like what? Object 1 is coming towards the object 2. Okay, va? So that is the concept of the relative motion study. With respect to 2 observe panna eppadi irukum? It is like object 1 is coming and colliding object 2. Other than a concept of relative motion. So we'll have the relative approach. So when they both are actually approaching relatively. So that is what you call as the before the collision. We will call it as before the collision. Artha stage during the collision. So so like if you talk about the case of the collisions where you actually have a physical contact, and we will have the 2 balls which are coming and having a physical contact. During the collision time, right, you may see some kind of a compression. Slow motion la paatha, like if you see even some of these movies, right, the hero guy will hit the villain and they will show in slow motion. So like you see in the slow motion means avangala skin jaw alla apdiye shake ana madri namakku theriyum. So what is happening there? There will be once this guy is hitting him, right, apparently the compression is happening. So that during the collision time there can be some deformation that is happening. Deformation and solala or compression and solala, whatever you want to call it. It may be temporary, it may be permanent also. Once the collision is getting over, if the objects are able to come back to their original shape and structure, right, what we'll usually call them as elastic collisions. Like if the objects are able to come back to their usual shape and structure, we'll call it as what? Elastic collisions. Like the way a spring is getting compressed, it will come back to the natural length, right, like elastic. Okay, so we'll talk about that later, but we will have the second stage is what? During the collision. So usually there will be the compression of the objects into one another. Okay, the object will start receding away. So collision முடிஞ்சதுக்கு அப்புறம் they will start receding away. அதனது if you look at it relatively இப்படி like we are observing with respect to வெச்சுக்கோங்க. It's like what relatively they will be moving away. So again நடக்கும் there will be relative separation நடக்கும். So before the collision என்ன ஆகும் relative approach. During the collision like objects are getting deformed or compressed. Sometimes it may be temporary, sometimes it may be permanent. Okay, so completely it is able to come back to the original shape and structure means we will look at it like what elastic phenomena. Okay, so adu patti we will discuss about it later. But third stage another after the collision, like when the objects are able to recede and move away. Okay, so if you look at the before stage and after stage, adula the interaction forces will not be present. And the interaction forces எப்போ act ஆகும், they will be acting only for the during the time. Interaction force will be during the collision time. So எப்போ act ஆகும் between these two stages means and the before the collision and after the collision. அந்த ரெண்டு ஸ்டேஜ் நடுல what is there during the collision தானா. So during the collision stage we will be able to see the interactive forces which will be large. Already நம்ம அதை பத்தி சொல்லிருக்கோம். What is it? The interaction forces will be what? Very large in terms of value. இன்னொன்று என்னன்னா like we will not be able to find out quantitatively. So on the interaction force oda value எவ்வளவுன்னு சொல்லிட்டு we will not be able to quantitatively find out. ஏன்னா there are very limitations in finding out what is that collision time. The actual collision time எவ்வளவுன்னு சொல்லிட்டு ஏன்னா there is a before process, there is an after. So actual collision during the collision time, right? So it will be a very small time value and there are limitations in finding that time. அதனால என்னன்னா the actual magnitude of this interaction forces, right, we will not be able to find it. Okay, so why we are not able to find it? Because the during the collision and சொல்லிருக்கு தெரியுமா, that particular time of that collision time, that will be very small value. Okay, so and because of that very small time interval, right, we will not be able to quantitatively find out what is the exact value of this interactive force. Okay va? So if you are not able to find out the force means paranga, if you are having a force value means we can talk about the Newton's second law. The force based panni what is the corresponding acceleration. But in the force value namakku theriyalana we will not be able to apply the Newton's second law. Okay va? So இது ஒரு important theory bit. Enadhu the interacting force during the collision time, right, adoda magnitude find out பண்ண முடியாது. ஏன்னா because the collision time is what? It's a very small time interval. Okay, அதனால we will not be able to find out what is the exact value of this interacting force. அந்த value நம்மளால find out பண்ண முடியலன்னா we will not be able to apply this Newton's second law. Okay va? So this is about the idea of stages of collision. Okay, அடுத்தது பாருங்க. So when we talk about this interacting force, right, ஒரு நம்ம என்ன சொல்லிருக்கோம், this is a large force. We said this is a large force, right? Okay, எப்படி அந்த large value எப்படி வருதுன்னு சொல்லிட்டு நம்ம பார்க்கலாம். So when you look at the collision phenomena, பாருங்க, like if you look at collision, right, maybe we have two objects or we can have many objects also. But என்ன நம்மளோட focusல we will try to mostly cover this collision between two objects. So nama purview la we will try to mostly give emphasis on what? Collision between two objects. Inga paranga, let's say there is a collision between two objects vechukonga. So what is happening is, inga paranga, so before the collision this object will have a mass m1, velocity v1. Okay, v1 ku badala we will use the symbol u. And generally before initial kanadi, what is the symbol we use? U, right? Initial velocity and so now we use the symbol u. Initial and so now what is symbol we use? U, right? Okay, so the collision முடிஞ்சதுக்கு அப்புறம் let us say the velocity of this is v1. Okay, so there will be a actually another, there will be a change in the momentum, right? This object will have a change in the momentum. Okay, but again, like the collision time is very small. Collision time delta t is small. This is a very small time value. Now England, what is the impulse force that we can find out? What is the impulse force? It will be what? The change in momentum divided by the time taken. So what is the impulse force acting on that object during that time of collision? What is it? Change in momentum divided by the time taken. Inga paranga, this is a very small value. It's a very small value. So paranga, so the denominator is very small, like it is in the range of microseconds, 10 power minus 6 and the madri. Then the impulse force value is going to be very large. Okay, the impulse force value is going to be very large. This impulse force is what we are going to consider as the interactive force. This impulse force is what we are going to consider as what? Interactive force. When you look at the collision, right, there may be some external forces acting like gravity and the madri. There may be some external forces acting on the objects. Okay, but these external forces, right, they will be very small in comparison to this interaction forces. The external force will be very small in comparison to interaction forces. Interaction force of the magnitude will be very high. Yeah, because if you look at this change in momentum by the time taken, right, அப்படி தான் நம்ம calculate பண்ண முடியும். So time taken, இதோட exact value நமக்கு தெரியாது. ஏன்னா because the time is very small interval and we will not be able to even find what is this delta t value correctly. Okay, so but we know it will be in the range of microseconds. So the interaction force value will be what? Very high in terms of magnitude in comparison to the normal external forces like gravity and the madri. So what we will see is that the external forces, right, we can neglect them. Neglect and so in comparison to what? This impulsive force. Okay, so during the time of collision only this interaction force will act. Okay, and the interaction force value will be very large. Why? Because the collision time is small. Okay, so the impulsive force will be what? It will be very large because of the small collision time. So we can neglect these external forces because the value of this interaction force is going to be very large in comparison to the external forces. Okay, and we neglect all the external forces. Neglect panna, what is it that you will see? It is like what? An isolated system madiri dana. That is the reason why we used in that initial discussion another, we said it's an isolated event and solirikum. What is the thing that we said? Isolated event. Why are we calling it as isolated event? Because during the collision time the external force or impact can be neglected. In comparison to this interactive force that will operate in that during the collision time, external force or value will be very small. Okay, so adanala we can neglect the impact of the external forces veru and the during the collision time mattum. Okay, so that is the reason why the collision phenomenon is also called as what? Isolated event. That is the reason why the collision is also called as what? Isolated event. Inga parunga, this interactive force, right, idu eppadi? The force acting on object 1 is because of object 2 dana. So other than the object 2 there is nothing else. Force acting on object 1 is because of object 2. And the madri force will be also acting on the object 2 because of object 1. Action reaction pair, right? There will be action reaction pair. So this impulsive force is because of the interaction between these objects which are undergoing the collision. The impulsive force is because of what? Interaction between the objects that are undergoing the collision. Okay, so which means this is actually what? It's an internal force. The external force, it's an internal force. Okay, now when we talked about the conservation of momentum principle in our Newton's laws of motion, when you have an object or a group of objects which we call as a system, if the net external force is 0, zero kadayadu, we are saying it is negligible. Why? Because the external force of the value is very small in comparison to the internal force. So adhanala we can neglect the external forces during that collision time. Okay, so if the net external force acting on that particular system of objects is 0, the total momentum, the total momentum of the objects, total momentum of the objects in sonna, we have to include all the objects. Let's say the two objects are undergoing collision. So total momentum means momentum of object 1 plus momentum of object 2. That's the total momentum. The total momentum of the objects will be remaining the same. Okay, so will be remaining the same means, let us say we are considering two objects. First object mass m1 ichukonga, adoda initial velocity u1. Okay va, mass m1, adoda initial velocity u1. After collision, let us say the velocity is v1. We have to keep one thing in mind carefully. Velocities are what? Vectors. Okay, the bar podala, but we should keep in mind that these are what? Vectors. And the object 2, adoda initial velocity is what? u2. Final velocity, so initial and before the collision, final and after the collision. So collision la, when we say initial and final, what is it referring to? Before and after. Okay va. So what is the initial momentum of that system? And the system oda initial momentum enna m1 u1 plus m2 u2. Adana, if there are three objects means plus m3 u3. Okay, what is the final momentum? So final momentum m1 v1 plus m2 v2. So when we say the total momentum of the system is conserved means what? m1 u1 plus m2 u2 will be equal to what? m1 v1 plus m2 v2. The individual objects of the momentum might change. Object 1 of the momentum might change. And the object 2 of the momentum also might change. Okay, va? The individual objects of the momentum might change, but when you look at the total momentum of the objects before the collision, which is what? m1 u1 plus m2 u2. We are taking only two objects. So now we will be mostly focusing on what? Collisions of two objects. But collision and so we can have three objects also undergoing collision, four objects also undergoing collision and the madri. Okay. So total momentum of the objects before the collision is equal to what? Total momentum of the objects after the collision. So every collision rate will satisfy this conservation of momentum principle. Conservation of momentum and it is for the entire system. One object it is for the entire system. Okay va? So this is a very important principle that we will use. In the result based we can solve some questions. But even some of the derivations we will do in the collisions, right? We will be using this conservation of momentum principle in the derivations also. Okay va? So we are not putting a bar, but we should keep in mind that u and v, they are representing what? Velocities which are vectors. U and v are representing velocities which are vectors. Okay va? So this is about the idea of conservation of momentum in a collision. Idhula point the thing is, why we are able to neglect the effect of the external forces. In the conservation of momentum concept use when the net external force acting on the system is 0. But in the conservation of momentum principle use because during that collision time, the impulsive force or that interactive force will have a very large value. So we can neglect the external force or impact. But in the impulsive force or that interacting force is internal. Object 1 will create a force on object 2, and the object 2 will create a force on object 1. Then it is internal. So we can consider that what? Since this large force that is acting is anyway internal, so we can neglect the effect of the other external forces. So we will be able to use what? Conservation of momentum principle. Okay va? So this is about the conservation of momentum principle for every collision. We can use this principle for every type of collision. After some time, right, we'll discuss about types of collisions, but any type of collision you take, we can apply this conservation of momentum. Okay va? The conservation of energy principle. Sometimes when we say the statement, right, a lot of people misunderstand this statement. Paranga, in a collision total energy is also conserved. In the statement path, some people will start thinking, so where we have studied somewhere that in some collisions the energy will be lost and solitary. So when we say total energy, the kinetic energy mattum kadiyadu, we are also including the other forms of energy. Let's say for example there are two objects which are colliding in vechukonga. Okay, so if there is a deformation, means what? Some amount of the kinetic energy of these objects is going into deformation. Means what? We can think of it like a deformation energy, the energy that is going in creating the deformation. Okay, that can also be looked at as a elastic energy madri. Okay va? And some amount of energy might be lost in the form of heat. Some amount of energy might be lost in the form of sound. Some amount of energy might be lost in the form of excitation of these electrons, etc. But whenever we look at it, right, when you add up all these energies, energy can neither be created nor be destroyed, right? It will only change from one form to another form. Which means what? If you look at the total energy concept, the all forms include panna, what you will be able to see? Total energy before the collision will be equal to total energy after the collision. But we will not be able to focus on all these different types of energies. We will try to look at only the kinetic energy of the particles. We will try to look at only the kinetic energy of the particles. So collisions are majority of the collisions, we will see that kinetic energy will be lost. Majority of the collisions, some amount of kinetic energy will be lost, which will be changed into the form of heat energy, light energy, sound energy, and only some theoretical examples, like when we go to the kinetic theory of gases, right, there we will say the collisions between the gas molecules and collisions of a gas molecule with the walls of the container. We will say that in those collisions the kinetic energy will not be lost. Okay, so on the concept based panni we will be able to classify the collisions. So based on whether the kinetic energy of these particles is conserved or not, based on whether the kinetic energy of the particles is conserved or not, adu base panni we will try to classify the collisions. Okay, but when we talk about the total energy, when we include all the forms of energy, right, the energy also, because energy can neither be created nor be destroyed. But we will not be able to analyze all the forms of energy. Energy forms analyze panna mudiyadu. So we will try to only focus on what? Kinetic energy mattum. Okay va? So based on this kinetic energy, or based on what is happening to kinetic energy, right, adu base panni we will try to even classify the collisions. Okay, so this is about the idea of conservation of momentum. So conservation of momentum will be valid for all collisions. And theoretically what we can say, conservation of energy also is valid. Conservation of energy and sonna, we have to keep one thing in mind. What is it? Energy means not just the kinetic energy. Energy means all the different types of energies. Okay va? But some forms of energy we might not be able to calculate or quantify. Adana we will shift our focus to what? This kinetic energy part alone. Okay va? So kinetic energy, will it be conserved for all the collisions? Means no. Okay, so there are some kind of collisions where the kinetic energy will be conserved, and some kind of collisions some amount of kinetic energy might be lost. Okay, on the basis of we even classify the collisions. We will see that how we are going to classify. Okay va? So this is about the basic idea of collision and how we will be able to look at the conservation of momentum and conservation of energy. Principle. Okay va? So the question paranga. So conservation of momentum, right, we can get some straightforward questions. Look at this two particles 1 kg 2 kg undergo collision. 1 kg is having initial velocity. So 1 kg mass or initial velocity. So u1 what is it? I plus 2j plus k. And final velocity, அதோட final velocity என்ன v1 2i minus j minus k. Okay va? What is the final velocity of the 2 kg particle? The 2 kg particle oda final velocity namakku venum v2 namakku venum. Okay va? If it has a initial velocity of I minus j, idoda initial velocity enna I minus j. Enna pananum? Because it is a collision, right? So momentum will be conserved. Means what? The m1 u1 plus m2 u2 is equal to what? m1 v1 plus m2 v2. Adana. So m1 is what? 1 kg, m2 is 2 kg. அப்படியே நம்ம எல்லா வேலையும் எடுத்துட்டு சப்ஸ்டிட்யூட் பண்ணோம், அவ்வளவுதான். பாருங்க. So check it up guys. Even you can also parallelly solve this and get the answer. Check பண்ணுங்க. So m1 is what? 1. 1 into u1 means அப்படியே அந்த I plus 2j plus k அப்படியே வரும். Plus m2 into u2 means 2 into this value. இதனது 2 multiply பண்ண 2i minus 2j ஆயிடும். Is equal to right hand side என்ன இருக்கா? m1 v1. So 1 into this one 2i minus j minus k. Okay va? Plus m2 into v2 which is what? 2 times of v2. Now பாருங்க, what is this? I plus 2i எவ்வளவு? 3i. Okay, so 2j minus 2j cancel ஆயிடும். Plus k. Right side லந்து we'll try to bring all these things to the left side. So 2i எடுத்துட்டு வந்தா it will become what? Minus 2i. Minus j it will become what? Plus j. Minus k plus k ஆயிடும். Okay va? So this is 2 times of v2. So பாருங்க, what is it? 3i minus 2i எவ்வளவு? I. அதுக்கப்புறம் j. k plus k எவ்வளவு? 2k. So I plus j plus 2k. அதானது 2 times v2. ஓகேவா? So அதுல இருந்து v2 எவ்வளவு? I plus j plus 2k divided by 2, which is what? Half I plus half j plus k. இப்படி எழுதலாம். So that is what is the final velocity of the 2 kg particle. Check பண்ணுங்க, what is the answer we must get? So Aditi, you are asking question. You are asking whether the why the total energy is conserved. See, total energy will be, so ஏன்னா பாருங்க, so what is going to happen to the total energy நம்ம discuss பண்ண மாதிரி. So some of the kinetic energy may be converting into some internal energy form or heat energy, light energy, sound energy, different forms. But overall if you look at it, right, the total energy can neither be created nor be destroyed, right? Okay, so even like say if you look at the energy converting into mass and mass converting into energy, that is the mass energy equivalence principle. Like if you look at nuclear phenomena, so nuclear phenomena only the mass will be able to convert this into energy form, and energy will be converting into mass form. Okay, so anganana we will try to quantify this in terms of the mass energy. So if no adinga nadakadu, normal collisions will not happen like that, right? Only nuclear collisions, because the nuclear phenomena also, right, that also we will see as a collision. So when we go to the nuclear phenomena, there we will discuss about it. Okay, so nuclear collision enna nadakum, the mass of the particles might be converting into energy form. Okay, or sometimes the energy might be converting into mass form. Mass can be converted into energy and energy can be converted into mass. Anganana you might think that energy is getting produced, because anganana mass will change into energy. So in the mass energy equivalence principle, right, adila enna we will say mass m is equal to how much energy? the mass m is equal to energy of mc square. That is what is the Einstein's mass energy equivalence principle, right? Adanal if you include everything, right, including that mass equivalent energy, ella nama include panna, what is it? We will see that total energy will be always going to be conserved. So enna nadukonna, it might change from one form to another form, avladha. Okay va? So is it clear? But idukapra we are going to focus on the kinetic energy part alone. All these other forms, right, we will not be able to calculate and do the problems. So nama kinetic energy mattum nama focus panna, what is going to happen? We will see that only some of these collisions, right, the kinetic energy of the particles will be conserved. Kinetic energy of the particles is conserved means what? The total initial kinetic energy of the particles is equal to total final kinetic energy of the particles. So that will happen only for some type of collisions, like na sonna madiri, the examples of collisions between the gas molecules or collisions between the gas molecules and walls of the container. And the we will take those kind of collisions. Like those kind of collisions, right, we will be calling them as elastic collisions. So what do we call them as? Elastic collisions. Okay va? Apdi kinetic energy conserve agalanna, we will call them as what? Inelastic collisions. We will see the classification. But ingenadi paranga, for any type of collision, right, we can apply the conservation of momentum. Okay, conservation of total energy adu nammala apply panna mudiyadu. Yenna the different types of energy, we will not have a formula, right? See, sound energy eppadi, how do you put a formula for the sound energy? Or internal energy of the deformed object, adukku nammala formula poda mudiyadu. Okay, so adanal enna, that total energy conserved is there. That is like a theoretical statement madiri da. Adu nama problems la kondu vara mudiyadu. Enna there are other different types of energy for which we cannot write an expression. Okay, so adanal enna, people try to focus only on what is happening to the kinetic energy. Okay va? So this is one kind of question paranga. We are trying to apply the conservation of momentum. The total initial momentum is equal to what? Total final momentum. Adalandi we are able to get what is the missing velocity. They are asking what is the final velocity of the 2 kg particle. So this is another question. This has come in the paper 1996. Paranga. A moving body of mass m and velocity 3 km/h. Okay, collides with another body at rest of mass 2m. First is what? M mass object. Adoda initial velocity 3 km/h. Okay, second object mass 2m. Adoda initial velocity 0, which is at rest and solranga. Okay va? So statement a moving body of mass m and velocity 3 km/h collides with a body at rest of mass 2m and sticks to it. So the collision kapram, what is happening? Both of them are sticking. Okay, so this kind of situation will happen in some type of collisions. Okay, so now we discuss panna porom. So we'll see in which kind of collisions this sticking will happen. The collision mudinadukku appuram the object will be sticking together and then moving. Okay va? So they are sticking and then moving together. Now the combined mass starts to move. What will be the combined velocity? So combined mass means what? Both of them will have the same final velocity. Okay, so both of them v1. So normally நம்ம என்ன சொல்றோம், the m will have a velocity after collision which is v1. அந்த மாதிரி 2m will have a velocity after the collision which is v2. But இங்க they both are sticking and then moving together, right? So combined velocity எவ்வளவு? v. அதுதான் உங்களுக்கு கேக்குறாங்க. They are asking what the combined velocity value. இங்க பாருங்க, what is the initial momentum? m into u1, which is m into 3. இங்க தெரியுமா, the value of the velocity will be in terms of km/h. Okay va? Plus 2m into 0, and this is at rest. This is the total initial momentum is equal to what? Total final momentum means finally both these are sticking together. Like what is the total mass now? M plus 2m, another 3m into other velocity and v. In the v then namak venum. This is what is our combined velocity. Okay va? So ipo parunga 2m into 0 means 0 dana. So enna varudhu? 3m is equal to inga enadhu m plus 2m inga 3m da. 3m into v. 3m 3m appadi cancel aidum. So v oda value enna varudhu 1, but what will be the unit? Kilometer per hour. So paranga, what will be the combined velocity of these objects? What will be the combined velocity of the objects? Enade, it will be 1 kilometer per hour. Okay, so how do we classify the collisions into types? So one basis enna, like on the motion of the particles. Let's say for example we have initially on the collision concept discussed பண்ணும்போது we talked about it. What is happening? The object is coming along this line, but the collision kappuram what is happening? They are going in, this is coming like this. So this type of collisions, right, where the velocities of the objects are along different lines. The velocity of the objects are along different lines. The initial object velocity is along one particular line. Collision kappuram the velocities, if you number them like 1 and 2, so the object 1 is having a velocity in a different line, object 2 is having a velocity in a different line. Okay, wow. So if the velocities of the particles are along different lines, that kind of collisions we'll call it as oblique collisions. We call it as what? Oblique collisions. So typically, say for example, you are looking at the collision on a plane, 2D plane, where the particles are moving in the plane. So these are all what examples of the oblique collisions. Okay, generally when this will happen is, let's say you have a mass m1 and mass m2. If these centers are not aligned in the same direction, so this is the center line for the m1, either the center line for the m2. If their center line or the lines of motion are not aligned, you will see that after the collision, right, generally there will be the motion which will happen in a different lines. Okay, so if the velocities of the particles, velocities and sonna, what is it? We have to include the initial velocities. We have to include the initial velocities and the final velocities. Okay, wow. So the velocities of the particles involved in the collision are not in the same line. Okay, then what do you call it as? Generally we will call it as what? Oblique collision and solo. Okay, what is happening? If an object m1 is coming and hitting the m2 like this, usually one will go this way and other will go in the other direction. Okay, wow. So we will discuss about these oblique collisions in detail, but this is what we call as the oblique collision. Like look at this now. The velocities are along the same center line. So u1 and u2. So if I look at this one, this is a case here in which so if m2 is moving slow, m2 is going towards the right side, right? m1 is also coming towards the right side, but then the m2 is slow. The m1 is going to approach, it will hit. Okay, wow. So the hit what you generally see, like somebody is going slow, back side some vehicle is coming and hitting. Immediately the object which is in the front, it will start moving fast. The object which is in the front will be starting to move fast. So this is one type of head-on collision. So this is what is called as the head-on collision or one-dimension collision. Okay, the velocities of the particles. Velocity of the particles and sonna, you have to include all the velocities. Initial velocity of the particles and the final velocities. All of them should be confined to one line. Confined to one line and sonna, don't misunderstand this with one direction. Or line la we can have two possible directions. Right? Look at this one. The m2 is coming towards the right. Sorry, m1 is coming towards the right, m2 is going towards the left. They are going to have a collision here. Okay, so collision if they are moving in the same line, then what is it going to be? Again, it is going to be head-on collision. So head-on collision, the velocities of particles, all the velocities, initial, final, ella inclusive. Velocities of the particles should confine to a straight line. Another velocity should confine to a straight line. Okay, அப்படி இருந்தா what do you call it as head on collision or one dimension collision சொல்லுவோம். ஓகேவா? So on the basis of the motion of the particles எப்படி நம்ம classify பண்ணலாம்? Oblique collision. Okay, so where the particles will be moving along different lines. ஓகேவா? And head on collision. நமக்கு என்ன தெரியுமா? நீட்ல mainly we will get questions on the head on collision. ஓகேவா? We can also classify the collisions on the basis of the kinetic energy of the particles. Basis of the kinetic energy and சொல்றதுக்கு பதிலா what we can say basis on what happens to the kinetic energy. அப்படி சொல்லலாம். எப்படி சொல்லலாம்? Like we can say it as what based on what is going to happen to the kinetic energy of the particles. இங்க பாருங்க இந்த பேசிஸ்ல we can divide the collisions into these three categories. என்னது? We can call them as perfectly elastic collisions னு சொல்லலாம். இது என்ன தெரியுமா? The kinetic energy of the particles initially. Kinetic energy of the particles னு சொன்னா we have to include all the particles. இப்போ பாருங்க there are two particles வெச்சுக்கோங்க. What is the initial kinetic energy means? Half m1 u1 square plus half m2 u2 square. That will be equal to the final kinetic energy of the particles. Half m1 v1 square plus half m2 v2 square. இங்க என்ன தெரியுமா? The individual particle energy might change. Like m1 kinetic energy might change. But total kinetic energy of all the particles before the collision, which is what? Half m1 u1 square plus half m2 u2 square. That will be equal to what? Total final kinetic energy of the particles. அப்படி இருந்தா then we will call this as what? Perfectly elastic collision. இது என்ன தெரியுமா? This is only possible in theoretical cases. Or அதுக்கு best example என்னன்னா the example that we can give an explanation for is the collisions involving gas molecules. Okay, அது தவிர most of the other common collisions we see, right, we will not be able to have this conservation of kinetic energy. Okay, and normally what you see, I mean, all the things that you have seen, right, like the cars colliding or whatever, the like you are hitting the ball with a cricket bat, you will see the sound, right? When sound is coming means what? Some amount of energy, kinetic energy actually lost. It is lost in the form of sound, heat. Okay, so perfectly elastic collisions where it is going to be possible between the gas particles or between the gas particles and the walls of the container. And the cases we'll have the perfectly elastic collisions. The kinetic energy of the particles, total kinetic energy of the particles before the collision is equal to what? Total kinetic energy of the particles after the collision. அது ஒரு சைடுல இருக்கு. ரெண்டாவது என்ன? Inelastic collision. Inelastic collision என்ன? What is this? The kinetic energy of the particles initially will not be equal to kinetic energy of the particles finally. The kinetic energy of the particles initially will not be equal to kinetic energy of the particles finally. In the majority of the cases, what is going to happen? There will be a loss of kinetic energy. Majority of the cases, நம்ம study பண்ண போற cases there will be a loss of kinetic energy. There is going to be a loss of the kinetic energy. Okay, so loss of kinetic energy, and what is the meaning of that? The final kinetic energy or value, right, will be less than the initial kinetic energy. Loss of kinetic energy, what is the meaning of that? The final kinetic energy of the particles will be lesser than the initial kinetic energy. So idhula enna nadakkum? Some of the kinetic energy will be lost in the form of heat, sound, light and the madri. Okay va? So this is what we mean to say by the inelastic collision in the general sense. Okay va? So inelastic collision sonna vadane what is the thing that you should come to your mind? Kinetic energy will not be conserved, which means Ke initial value will not be equal to Ke final. This is the main concept of inelastic collision. But majority of the cases loss of kinetic energy. Majority cases loss of kinetic energy. Okay va? Which means final kinetic energy of the particles will be lesser than the initial kinetic energy. And the right side what is it? Perfectly inelastic collision. Perfectly inelastic collision and some of us might think that okay, idla final kinetic energy zero I don't say it, but it is not going to happen. perfectly inelastic collision la final kinetic energy will not become zero. Perfectly inelastic collision என்ன தெரியுமா? Because இப்போ பாருங்க inelastic collision னு சொன்னா we are saying there is a loss of kinetic energy. In a perfectly inelastic collision அதுல என்ன நடக்கும்னா loss of kinetic energy is going to be the maximum. Normally நம்ம inelastic collision னு சொன்னா அதுல kinetic energy loss வரும். But when we use the word perfectly inelastic collision அது என்ன ஒரு particular situation or scenario we are going to discuss about it. Okay, so அந்த particular scenario என்ன ஆகும் தெரியுமா? The loss of kinetic energy is going to be maximum. So அதுக்கு நம்ம என்ன சொல்லுவோம்? Perfectly inelastic collision. This is also sometimes called as என்ன தெரியுமா? Plastic collision னு சொல்லுவோம். So what is it called as? Perfectly inelastic collision can be also called as what? Plastic collision. Okay va? So this is about how do we classify the collisions based on what is going to happen to the kinetic energy of the particles. I told one interesting thing. In majority of the inelastic collisions we are going to see kinetic energy loss. That means what? There can be some inelastic collision where initial kinetic energy value is not equal to final kinetic energy, but the kinetic energy might increase. So when the kinetic energy will increase, when some internal energy like chemical energy and the madri, some internal energy of the particles changes into kinetic energy form. So the exceptional cases is that if some of the internal energy that is the chemical form of energy and the madri, some of the internal energy is changing into kinetic energy form because of what is happening during the collision time. Apparently we might see that the final kinetic energy of the particles is more than the initial kinetic energy. Okay va? So either we discuss we are going to look at what inelastic and the main idea is okay, initial kinetic energy value of particles will be different from final kinetic energy. Maximum case we are going to see loss of kinetic energy da. But theoretically we can also have a inelastic collision where the final kinetic energy is more than the initial kinetic energy. Then we see that during the collision time, right, some of the internal energy of the particles like the chemical energy form and the madri is going to change into kinetic energy form. Okay va? So if that is happening means then we can have that situation. Okay, so this is the classification. So for the classification based on we can look at totally arrangements varum paranga. So perfectly elastic collision, we can have perfectly elastic collision in the head on type. Head on means what? One dimension. Idana maximum paaka porom. Or we can also have the perfectly elastic collision in the oblique manner. Okay, we can have inelastic collision in the 1D. We can have inelastic collision in the oblique manner. We can have perfectly inelastic collision in 1D, and we can have perfectly inelastic collision in the oblique manner. So totally how many arrangements varum? 6 arrangements we can get. But idhula enna theriyuma, na sonna madri our focus will be mostly on what? The head on type. So head on type la we are going to we'll study about the oblique also, but major focus enna we'll have to keep on the head on type. So head on perfectly elastic, head on category la inelastic, head on category la perfectly inelastic. Okay va? So this is the different combinations of collisions we can have. Okay, so in collision, right, collision is basically what? The phenomena where you are having the impact. So the important term and the coefficient of restitution. So what is the term called as? Coefficient of restitution. So then this is a term that is generally used to represent the impact of the collision. This is a term that is generally used to represent what? Impact of the collision. So there are main significance when we use this for the head on type or 1D type. The coefficient of restitution will have most of its meaning when we use it for what? The head on type of collision or the 1D type of collision. So what is this coefficient of restitution? Now when we talk about the collision, right, let's say there is a mass m1, this is the mass m2, either the initial velocity u1 வச்சுக்கோங்க, இது இனிஷியல் வெலாசிட்டி என்ன u2. ஓகே, ஸோ அப்படியே மூவ் ஆயிட்டு we will see the collision time. இங்க பாருங்க, both of them will come to the same point. This is the collision time. This is what before, this is during. The collision முடிஞ்சதுக்கு அப்புறம் what is going to happen? m1 m2. So m2 is going to go with the velocity v2, m1 will have velocity v1. அப்படிதான் நடக்கும். This is the typical collision. We are looking at what 1D type of collision. Okay, so இதுல என்ன, the coefficient of restitution rate is defined as the relative velocity of separation. இது எப்ப நடக்கும்? after the collision. Okay, so relative velocity of separation after the collision, okay, divided by the relative velocity of approach. When we'll have approach, relative approach எப்போ வரும்? When the collision is going to happen, right? Which means before the collision. So that's the definition. What is the definition of the coefficient of restitution? It is what? The relative velocity of the separation after the collision divided by the relative velocity of the approach before the collision. Okay, wow. So what is the definition of the coefficient of restitution? Paranga, the relative velocity of the separation after the collision divided by relative velocity of approach before the collision. Inga paranga, what do you mean by the relative velocity of the separation after the collision? Okay, so paranga, so before the collision நம்ம என்ன யோசிச்சிட்டு இருக்கோம்? This is moving slow and this is moving fast. Okay, the object 1 is moving fast, object 2 is moving slow. So here we can say the relative velocity of approach and sonna, what is it? u1 is having, let's say for example paranga, u1 5 meter per second வச்சுக்கோங்க, u2 எவ்வளவு 2 meter per second. இப்போ relative velocity of approach and sonna, what you will give? 5 minus 2, அதுதானா? So what is it going to be? u1 minus u2. Relative velocity of approach and sonna, what you are going to give? u1 minus u2, அதுதானா? Collision க்கு அப்புறம், this is after the collision, right? This is after collision. Let's say, you know, the object m2 is moving with a velocity 3 meter per second. Then this is going to move slow now in comparison to m2. m2 the faster move ஆக போறது. So இங்க என்ன பாருங்க, the relative velocity of separation and sonna, what is it going to be? Then it is going with 3, this is going with 1. What is the relative velocity of separation? Means 3 minus 1, which is what? v2 minus v1. What is it? v2 minus v1. That is the relative velocity of separation. இப்போ பாருங்க, what is the e your value going to be? Relative velocity of separation after the collision, which is what? v2 minus v1 by relative velocity of the approach before the collision, which is what? u1 minus u2. என்ன தெரியுமா, order change ஆடும், அதை நம்ம கரெக்டாக ஞாபகம் வச்சுக்கணும். What is it? It is what? v2 minus v1 by u1 minus u2. ஓகேவா? ஸோ இப்படி தான் நம்ம எக்ஸாக்டா அந்த ஃபார்முலா எழுதணும். பட் இஃப் யூ take a modulus means it does not matter. என்ன modulus எடுத்துன்னு வச்சுக்கோங்க. To take a modulus means whether you write v2 minus v1 or v1 minus v2 does not matter. ஏன்னா நீங்க modulus போட்டா what is going to happen? Anyway you will take the absolute value only. Modulus போட்டா you will take the absolute value only, right? But if you want to write the exact formula means இப்படி தான் எழுதணும். What is it? v2 minus v1. அதனது relative velocity of separation after collision divided by u1 minus u2. So the significance எப்போ வரும் தெரியுமா? The analysis of this coefficient of restitution, this is more significant for the head-on type of collision or the 1D collision. Okay, ஏன்னா that line where we are discussing about relative velocity of separation and relative velocity of approach, right? That is the line of impact of force. That is the line along which the collision force is acting, right? So adhanala this coefficient restitution rate for an oblique type of collision people don't talk about it. Okay, so in the analysis that is not going to be very much useful in the oblique type of collision. Enga idu useful irukum because we said, right, we are going to mostly focus on what 1D collision. On the 1D collision this parameter will be useful. Another, the coefficient of restitution, it is what? The ratio of relative velocity of separation after the collision divided by the relative velocity of the approach before the collision. Okay va? So we'll see நம்ம ஒரு category of collision ஓட discussion பண்ணும்போது we'll see how the coefficient of restitution ஓட value change ஆகும்னு சொல்லிட்டு, because each type, right, போட்ட மாதிரி like we are going to discuss about these the 6 categories நம்ம பார்க்க போறோம். But main என்ன we will focus on இந்த மூணு head on category ல perfectly elastic, அந்த மாதிரி inelastic, அந்த மாதிரி perfectly inelastic. அதுக்கப்புறம் we'll also look at this one, எப்படி இந்த expressions வரும்னு சொல்லிட்டு we can also look at perfectly elastic collision in the case of the oblique type. Okay, அதே நம்ம அப்படியே பார்க்கலாம். But so focus என்ன, we have to focus mostly on the head on type of collisions. Okay va? So this is the concept of coefficient of restitution. So this is the question that has come in the NEET 2018 paper. So this is straight on the finding of the coefficient of restitution. Paranga. So enna panna, we have to just find the value of the coefficient of restitution. A moving block having a mass m collides with another stationary block. Stationary nu sonna what is it? This is at rest. Paranga, moving block of mass m is colliding with a stationary. Ipo idoda velocity enna? Okay, so what is this? When the initial velocity of the lighter block evvala v, means the initial velocity evvala v, idoda initial velocity 0. Okay va? So moving block of mass m collides with another stationary block having a mass 4m. The lighter block comes to rest after the collision. So after the collision enna aitirka? So paranga, this is the collision, right? After the collision, the lighter nu sonna the block with mass m, that is coming to rest, means collision ku appuram adoda velocity is becoming what? 0. When the initial velocity of the lighter block evvala v, okay va, then the value of coefficient of restitution evvala nu solittu kekranga. Inga paranga, the m is coming to rest means 4m will start moving, appadana. So let us say 4m oda velocity ninga v dash nu vechukonga. 4m oda velocity enna v dash. So eppadi indha v dash calculate pandrathu paranga, we have to calculate the value of v dash, right? Inga enna theriyuma, before we go and calculate the value of v dash, inga paranga, before the collision 4m eppadi irukka? Stationary. Verum in the lighter mass mattum it is moving and coming. What is the velocity with which it is coming? V. So paranga, relative velocity of approach, adana v dana, ena 4m is at rest, and the bakkala m appadiye vandittu irukka. What is the relative velocity of approach? V. Okay, v dana. And relative velocity of separation. So collision ku appuram what is happening? Paranga, m is coming to rest, 4m is starting to move with how much velocity? V dash. Ipo relative velocity of separation evla? V dash. Okay va? So inga paranga, E is what? V dash by V. Adha E oda value. So E oda value enna? V dash by V. So E namakku venumanna we should find out what is the V dash value. Calculate panna, we should calculate what is the V dash value. Eppadi calculate pannalam paranga, we have only one principle. What is it? Conservation of momentum. Adana. So what is the initial momentum? Verum in the lighter mass mattum will be having the momentum initially. And 4m is having a 0 velocity. Paranga, m into v plus 4m into 0. 4m into 0 means 0 only. That is the total initial momentum is equal to total final momentum means what? M into 0 plus 4m into v dash. Okay, so left side enaka m into v is equal to 4m into v dash. M cancel pannunga. So v by 4 is equal to v dash. Adana, what is the v dash value? V by 4. அப்படி எடுத்து நம்ம சப்ஸ்டிட்யூட் பண்ண, அவ்வளவுதான். சப்ஸ்டிட்யூட் பண்ண என்ன வரும் பாருங்க, v dash பதிலா நம்ம என்ன சப்ஸ்டிட்யூட் பண்ணனும்? v by 4. சோ பண்ணுங்க, v by 4 divide by v. இதனது v கேன்சல் ஆயிடும். 1 by 4. 1 by 4 சொன்னா what is it? 0.25. 1 by 4 சொன்னா what is it? 0.25 தானா? So that is about the coefficient of restitution. Check panna guys, what must be the answer? It should be what? Option B. So coefficient of restitution means what? Relative velocity of separation after the collision. Collision ku appuram. That is actually what, if you are having two objects means v2 minus v1. Okay, like how we got this. If you are trying to just look at this, no, if you are trying to use that formula, some people might think, why can't we use that same formula, and so you will be thinking, right, we can use the same formula. So u1 evala v, u2 evala 0, v1 evala 0, v2 is equal to v dash. What is the formula we have? V is equal to what? v2 minus v1 by u1 minus u2. So v2 evala v dash minus v1 evala 0 divided by u1 evala v minus u2 evala 0. So what is it? V dash by v. As it is, we the formula and use panni. Okay, but otherwise if you are a little bit comfortable in terms of the relative velocity concept, right, appadi nama straight ah. Okay, so initially it is like what? 4m is at rest, m appadiye vanditrukka. What is the velocity of approach? V. Collision kaprom m is at rest, 4m is going away with the velocity v dash ichukonga. So what is the relative velocity of separation? V dash. Okay, appadiye nama eludala illana you want to go as per the formula means appadiye the formula base panni we can write it. What is the formula? v2 minus v1 by u1 minus u2. Okay va? Good. So Aditi, Maithili, good. Okay, so we have completed the initial discussion about the collisions. So next session we will start with the or type of or category. So first head on lende paaka porom. So head on elastic, adukaprom head on inelastic, adukaprom head on perfect inelastic. Mudichittu we will also try to look at the elastic type of collisions in that oblique category. Okay va? So we will start about those things in the next